Advise you to make sure you attend with your students, and there are dismissal times for each of those groups. We'll start with the seniors, move to juniors, then to the sophomores. Freshmen, they will report to the theater at the time listed on the board set last week. Mr. Sire will meet with the freshmen during that time. Lunch today, soft shell taco, baked fish and cheese, turkey and cheese sub, and salad.
An unexcused absence is a Saturday school like any other time. However, if your parents call you out for that period, then it's an excused absence and you never have to make it up.
Applications are due by April 1st. I did resend that email to you this morning. Make sure you get your application in. Check your email again for what you need to fill out. All junior boys eligible for boys' day. Tennis pictures today, 4:45. Boys soccer meetings today.
I have not.
Today is going to be a great
Part
day.
of the freshman impact kit. You would meet in the high school lobby March 29th and March 31st at 6 o'clock. You can find help with freshman impact another way is volunteering today at the program. You can visit with Officer Gillette as soon as possible. Noted with freshmen
Do the daily quiz.
That's the program that sets freshmen health. Please only available sophomore, junior, senior. That day is Memorial Day on April 25th. Freshman impact program. And $5 blood drive, March 4th, 3:30. If you're 17-year-old and you would like to donate, you must have my consent form signed. Please contact me from the license birth to sign up to donate. Remember, you may not miss class, only important time, or during your free walk. Take part in the blood drive, that vehicle will be parked in front of the high school.
Incorrect. If you do the blood drive and you can show me proof of it, all of this is on YouTube. You can do it during this class if you want.
Complete applications are due on March 31st. Information on the announcement page. Running out of time to apply for the Department of Budget Booster Club scholarship.
No, you just said it.
$1,500 scholarships in 2 weeks. Stop in the activities office.
Oh, you mother.
All these things. Keep it flat.
Well, my spatula broke, so one of you is getting a brownie pile. Two of you are getting a brownie pile. These are mushy. I hope whatever other conversations are taking place, they are doing after our daily quiz, right? Because we always attend to our responsibilities first and then the fun stuff, not stay up till 2 a.m. doing the work because we were playing games for 4 hours before that, right?
We would never do that.
Oof. The red battery warning means it's good for another 3 days. I have not charged these calculators since the beginning of February. They last that long.
One time at the Algebra 2, I made a calculator that was like blinking red last for nearly a month.
Finish the daily quiz, then compare notes.
Did we just take quiz 6? Or is this
Yes. I started quiz 6 and actually passed out on my desk. I don't remember whose, but I'm sorry. I drooled on one of your tests. Like, I legit passed out on my desk. So it was only a little bit.
We'll see.
So you just go stick
Is anyone still going on the daily quiz? Hearing no objections. Okay, up top. When it talks about showing properties, if you just that, that, and -1, because that cancels. Those are showing properties. Okay, you understand what cancels. For here, if I say 5 to the what is 5 to the -3rd. Okay, that works. So yeah, there's a lot more here, just like there was, I think, 8 or 9 problems for the homework, because some of them are just right number. Okay, down here, you got parent function. Every time that I have a new base, it's a new parent function. In this case, log of x base what? Common log. Yep. We got 4 things that happen to it. We have our vertical translation, down 1. We have a horizontal translation, left 4, bass-ackwards land. We have a vertical stretch by factor of 2, and remember that the negative is a separate transformation. That's going to be a vertical reflection or reflect in the x-axis. So I would normally have a vertical asymptote at 0. I'm going to take that asymptote and move it back 1, 2, 3, 4. I would normally have a, no, stop that. I would normally have my initial point of log of 1 is 0 kind of thing. I'd have that initial point on the x-axis 1 away from the asymptote, but this thing got moved down 2, or down 1, sorry. Then the vertical reflection says I'm going to head, instead of up and curve, I'm going to head down and curve. And the vertical spacing between them is going to be twice as far. So from here, this is kind of like my crosshairs, I will head down 2 and over 10. 2, 3, 4, 5, 6. Vertical stretch of 2. The vertical spacing in it is twice as far. Remember, the powers don't change. The only way that I change the horizontal stretch or compression is if there's a, well, we don't call it a B value anymore. If there's a value, I don't remember if it was this class or second hour, we're arguing about what letter to put there. Some wanted M, P, Q, D, whatever, and it just became a whole thing. But if there's a value here, that's what stretches the powers out. Instead of going up 1 and over a tenth, I'm going to go up 2 and over a tenth. Okay. And honestly, that's the 3 points that I need to get my curve. Why are you way up there? Why are you way up there? We will curl along that asymptote and then take off to the right. Okay. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Again, there's a lot of things up here, but they're all very, very tiny. So what I'm going to kind of do here is I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. I'm going to say half a point each, round down. So if you got only one of those 10 things wrong, 4 out of 5. If you got 2 of those things wrong, 4 out of 5. 3 of those things wrong. Okay, now we're looking at a 3 out of 5 because seriously, they're all just little things. Okay? Anything about it? Handed back quiz 5. It went very well. Making me and your Algebra 2 teachers proud because that was the heart and soul of Algebra 2 was can you solve and create polynomials even when they get butt ugly? Okay, that one went very well. We had multiple hundreds on it. Homework? Okay, 22. Oh. Log base 7th root of 4 is really disgusting. I'm saying that to this power equals this thing. Well, if I understand that 7th root of 4 is 4 to the 1/7, remember our rational exponents? And then I know that 4 to the 1/7 is going to be taken to some power. And that's going to equal 64, but 64 is 4 to the 3rd. The one-to-one property on exponents, which we'll talk about more with solving them tomorrow. 1/7 x equals 3 times by 7. And you should be able to do that in your calculator if you have the 7th root of 4 and take it to the 21st. It better equal 64. And then you could also just simplify that, right? That's 4 to the numerator, denominator. Well, that's 4 to the 3rd. Okay. But we have to use our rational exponents to get there. The rational exponent thing, that's going to come back to us tomorrow. Okay, as part of solving exponential and logarithmic equations. Okay. Moore's? Nothing? Okay. Again, I fully intended to have all of your stuff in last night, but sleep deprivation said otherwise. So 6 is the last thing. I have all of your daily work minus, who was that no-name black notebook that was taken off of my desk? All right, put your name on there. I need that back because I had no idea who you were. A whole notebook and like 4 packets of notes and not a single name. Come on, man. It's like second rule of kindergarten. So,
Now what is the
don't bite anyone.
I was gonna say it's probably don't bite.
Yeah. Yeah, anyone who's been in my room before knows the story of Shauna Warnke and her scar. So 3-3, good to go? Okay. Just so I remember, I know today's an advisory day. Was there anyone who has not yet taken quiz 6? Come down today after the advisory thing? Okay. I'll just leave that one blank. Okay, it's not your fault if we have an advisory, just like all the kids who tried to come take a test and I was gone for like 3 Spartan times in a row. Okay, I think me and Brooke had scheduling difficulties for a month. So, not your fault. I'll just leave that blank in the grade book. Come do it on Thursday. Okay. Just want to make sure so I got anything right. The advisory thing, y'all know you go to your Spartan time teacher first. They give you this cute little sheet because apparently it's still the 90s and we don't know how to use digital apparatus. You can get one of these, you roll around and you just kind of have them check off or sign or whatever initial. You have to go to X amount of them to say, look, I actually was there, because then that's your attendance and these get turned in. Okay. Seniors and then juniors and then sophomores. Seniority is the way of the high school. Okay. So, hey, they got free stuff. They're gonna have like little flashlights and they're gonna have keychains. I really like the pens that got the little nubbin on there so you can use it on your phone, because that's how I write on stuff to send back to kids when they ask questions. If you actually ask questions. Oh God, no! That environment is way too noisy. I'm not going down there. I don't like crowds. Crowds freak me out. But that is what you're going to do. You go to your Spartan time, and at your designated time, they're going to release you to go down there, and you have to have so many of them sign off to say, look, I was actually here. Okay? But there's no makeup date for it, so if someone was absent because their parents called them out, well, then there's nothing to be done about that. 3-3. There are properties of exponents, so there's going to be properties of logarithms, and they're going to be very, very similar. Yes. Okay. A, I had a broken spatula. B, Mom Bear said that the brownies came out of the oven while Baby Bear was doing his at-home speech. So the middle was a little mushy. Some of you are going to get brownies. Some of you are going to get brownie-flavored piles. They still taste good. Go. There's forks to the left.
It was amazing. Are you jealous?
Yeah, some of them were just straight up a pile. Come on. Remind me what happens when I take x to the a times x to the b. Because logarithms are the inverse of exponents, logarithms have a very similar property. It says if I have log of x plus log of y, then I can smack those two together and say that's log of xy as a product. Okay? Log of a product is sum of logs. I had another one that said if I take x to the a divided by x to the b, it's the same as x to the a minus b. Well, very similar. Log of x minus log of y is log of a quotient. Okay, log of a quotient is a difference of logs. You see how related they are. And then there was the power property that says if I have log, I hope it's understood that all of these can have log whatever base. I'm just using common log because it's easier to write. If I have log of some object, and that object has a exponent, that exponent can go from coefficient to exponent and exponent to coefficient. It can go in either place. Okay, so the way it's really written is if I have a log of x, that's the same as log of x to the a. Okay. There's usually some stupid meme as we're talking about, like get down or get in the chopper. And there's a whole thing about it. There was a video like 15 years ago. It's for old people, like MySpace level memes. So those properties are going to be used to do a bunch of stuff. We're going to use them to evaluate things that we otherwise wouldn't be able to. We're going to use them to expand things, to condense things, to eventually solve equations that are a little bit too ugly. Okay, so those three properties are where it's at. Oh, something to be very careful about with this guy. And sometimes we screw this up. What if that was something like log of 4x? And 4x is the object of the log. I have to remember that when I bring that coefficient up, it goes to the whole thing. Now, where we tend to goof that up is when this is actually a number. Say this is 3 log of 4x. That's the log of 64x cubed. Because I have to cube the entire 4x. Okay? So that's one of those little things that we get caught in a trap. And as you see, handing back another round of quizzes, that little thing, boy, the number of us that are sitting at that 28 out of 30 see our negative or something and then just table flip. Okay, it's one of those little things you might want to make a note about just because sometimes you get caught. Okay. I went through like what actually is on the quiz, like all the marks and what they are, right? Or was that second hour? Oh. It's pretty simple. Every question is out of 5, unless it's one of those tests that only has 5 questions on it. Then the bigger ones are literally worth more. You got one wrong. Everything after that is crap. Domino effect. But I'm not taking points off for the other stuff because you still did what was right after that, just based on incorrect information. Reduce. For crap's sake, you're in PreCalc. Reduce it. I didn't take points off, but I ain't happy. You did something. We talked about that thing. Why did you do this? Frowny face of doom.
What if it's just like a regular
But regular frowny face? That's more, I'm not angry, that's, oh, why'd you do that? But it's still no points off. The little asterisk is the point off. I just count those, okay? I'm not mad, I'm disappointed, yep. Okay. All right, here we go. Express each in terms of ln of 2 and ln of 3. Remember, this works for all logs, whatever base. You may remember this from Algebra 2, and the key to it is before you go trying to break things up, break up the object of the log by their prime factors first. Now, if you don't know off the top of your head that this is the ln of 2 times 3 cubed, then you might have to go old school. Y'all remember factor trees? Okay, if you got to go old school and go factor tree on it, then you go right ahead. Say 54 is 6 times 9, that's nice. 2 times 3, that's 3 times 3. And then the prime factors are 2, 3, 3, 3. So I rewrite it as the ln of 2 times 3 cubed. And then it's a product. What do we do with log of a product? Can be rewritten as a sum of separate logs. So this turns into the ln of 2 plus the ln of 3 cubed. What else could I do to it? Bring the 3 down. It's a power property, right? So I'd say it's the ln of 2 plus 3 ln of 3. That's what they mean by write it in terms of ln of 2 and ln of 3. They don't want ln of 27, which is 3 cubed. They want ln of 3. Well, I have 3 of them. Okay? ln of 9/8, same thing, but I don't think we need our factor tree for that guy. That's the ln of 3 squared over 2 cubed. What do I do with the ln of or any log of a quotient? Turn it into a difference. So now this is the ln of 3 squared minus the ln of 2 cubed. And then you tell them, get down. Those 2's come down, 2 ln of 3's. That 3 comes down, 3 ln of 2. Remember, every time you change the base, it's a new log. Every time you change the object, it's a different kind of term. I cannot add together ln of 3 and ln of 2. I have seen someone try to freshman math this and say negative ln 1.
Yes.
Oh, wait. ln of 1 is just 0, so negative 0. 0! The answer is 0. No, it's not. Don't do that. Okay? That's it. That is your simplified expression answer. Okay? There's some tips and tricks that you can use with this. Like, for example, if I have 0.018, I can turn that into a fraction, right? I can say that's the ln of 18 hundredths, or thousandths. And then I can break those up by prime factors. Okay, so you can do this with decimals. What else? Be careful about denominators. Say it was the ln of 9 over 24. That's now the ln of 3 squared over 3 times 2 to the third. You can reduce it. You can do stuff like that. Anything that's on denominator, say it was 9 over 40. Well, now that's 3 squared over 2 cubed and 5. Remember, you're going to subtract both the ln of 2 cubed and the ln of 5. Even though they're multiplied together, they're both on the denominator, so I'm dividing by both of them. They will both be part of my difference. Yeah?
So, the one that has the numerator of 9,
Uh-huh.
and you cancel it out, would it be 1, and then how would you write that out?
No, I would leave it like this, and then I would go.
Okay.
Okay, so there's all these little tips and tricks depending on our exponents and how they break up, but in terms of log of 5 and log of 3, break them up. Always break them up first, then start separating out your logs. Always go to prime factors, then separate your logs.
You cancel something out, variable on the top. Let's say it's like 2 squared or something.
You would have 1 minus ln of 2 squared. Yeah. In fact, we're going to see that with some of our condensing and expanding. That is going to pop up. Okay, prime factor tree. Make sure you know your prime factors. Terminating decimals can be turned into fractions by their place value. Okay, there are some calculators that have apps or functions built into them that will actually do prime factorization for us. That's fun. I know we use a graphing calculator an awful lot in here, but did anyone have this? The black and silver one? 36X Pro? If you do, you can just type in any number. Math, option 4 is prime factorization. So it just does it for you. That's handy. I know I've seen it on a couple other things. It's in one of the apps that you can download on a calculator. Or on a TI. It's some of the Casios have it in one of their function operations menus, but sometimes it's helpful. So if I have log of 3 times 5 squared, log of a product is the sum of separate logs. And exponents can become coefficients. If I see the log of 5.4, well, that goes out to the tenths. That's 5 and 4 tenths, or also log of 54 tenths as an improper fraction. Okay. I can reduce it. Call that log of 27 fifths, which then starts to look a lot more familiar. That's the log of 3 to the third over 5, which is log of 3 to the third. Most of us are probably cool with just bringing that 3 down right away, minus log of 5. Okay? Pretty straightforward. Okay? So I can use this to simplify and evaluate different logs. Like what happens if I'm able to break it up in such a way that it's log of 10 and a thing? Well, it's already base 10. So if I have log of something 10, well, that's just 1. I can use this to start evaluating things that otherwise I would have had to just run to the calculator for. It also helps with my expanding and condensing logarithms, which I will need to solve equations and later when y'all head to calculus, do derivatives. So, can you evaluate it using the properties? Well, that's log base 4 of 64 to the 1/5. I have options. Option 1 says I just run with this, bring that 1/5 out front. Log base 4 of 64 is 3. So 1/5 by 3. Option 2 is what if I had at the beginning turned this into base 4? Then that would be log base 4 of 4 to the third to the 5th. Because now, when that comes out front, I have 3/5 log base 4 of 4, which is 1. Okay?
Why did you divide these right up?
Because remember that when I have the 5th root of 4 to the third, it can also be written as the 5th root of 4 to the third, like that. Both of them are to the 3/5 power. Okay? So you're going to start seeing this with logs and exponents. Remember that because they're about repeated multiplication, multiplication's commutative. That means the order doesn't matter. So you're going to start seeing there's maybe 2, 3, 10 different ways to solve the problem. For part B, 2 options. Option 1, I'm going to bring this 2 down to join the 5. 10 ln of e minus, bring this 3 down, and get 3 Lenny. And we know that the ln of e is 1. So that's just 10 minus 3. Option 2 says I could have actually brought that 5 up instead and had ln of e to the 10th minus ln of e to the third. But then I know that cancels and I get 10, that cancels and I get 3. So you can bring that coefficient exponent in both ways. It's really a matter of personal preference. And they both have different utility. Depends what you're trying to do with the problem. Sometimes you want to throw everything up in the chopper. Sometimes everything has to get down. Okay? All depends what you're trying to do. Either way, as long as you follow math law and get to the end of the rainbow, we're good. Get them? Hmm. Doesn't matter which way you do it. Both ways, you end up at 2/3. Right now, I could just not move anything. Cancel that out, it's 9. Cancel that out and bring this down as a 4 times 3. Okay, I don't actually have to move anything on that if I understand that those properties can be used interchangeably. Or you could bring the 4 up and join it to 12, cancel. Or you could bring the 3 down, it's a 12, cancel. Bring the 9 down, cancel. Whichever way you're going. Okay, all you got to know is that Lenny cancels down to a 1. So, what do you think? Good so far? Any of those 4 a little sketchy? Want to see it just to be safe?
For, oh, never mind.
Speak your piece.
No, I think we're good.
Okay.
I didn't know that.
Notice that it says in terms of ln of 10 and ln of 3, but 10 could have been broken down into 2 and 5. Okay. Don't know our powers of 3?
Isn't that like step 7? No, that's 8.
3, 9, 27, 81, 243, 729. So that's the ln of 3 to the 6th and 10 to the 1, 2, 3, 4. I could actually count this time. So I'd call it ln of 3 to the 6th, bring the 6 out front. ln of 10 to the 4th, bring the 4 out front. Okay. We should know 729 as 9 to the 3rd. You should know squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can memorize, because they will keep cropping up in here. Ooh, yeah. So, expanding. The idea is you're going to get a log and you want to, like, Tony Stark on it and turn it into this big smattering of numbers. Some of them are going to get really long. but you're going to use the properties to do it. Stage 1, you break things up as products. This is this times this times this, right? So, log of 12 plus log of x to the 5th plus log e negative 2. Exponents become coefficients. And 1 off on the problem on your test. This is not expanded fully. Can you see anything in the objects of the logs that might be rewritten as a product? You can break up 12. Okay. What we should have done right from the get-go is all the way back here, I should have turned this into 2 by 2 by 3, prime factorization. So that's log of 2 squared plus log of 3 plus. Make a note next to this. The directions tell you to expand, the very first thing you should do is break up any coefficients as prime factors. Because it really sucks to get to the end of your problem and maybe you said log 4 plus log 3. You're like, but I broke it up. What can you still do? You can call this 2 squared. That should not be log of 4. That should be 2 log 2. Okay? You have to break it up as much as possible. You do not find your new element by staring at the big chunks. Yeah, that's everything. That's it. On to this guy. We have run into this problem. I keep seeing kids try to do this. And that bothers me so much. Stop that! I can only take factors out of radicals. Radicals are about what multiplies together to make this, not what added together makes this. As soon as there is a plus or a minus in there, you have to rewrite it in terms of factors. Now, could I do 4x plus 1/4? Okay, now it's a factor. Now it's something times something else. I can take that out. But y'all, you can't just, I see something that's squared, gone. It doesn't work that way. Instead, since that is a sum in the radicand, I'm just going to leave it there. Okay? So that is the ln of x squared. This is on my denominator, so it's the ln of that whole thing, 4x plus 1. Could I rewrite that 4x plus 1 a different way? As a 1/2 power. So I'll say 4x plus 1 to the 1/2 power. Say what?
Like ln 4x plus 1 over 2.
No? Oh, okay, your final answer. Okay, yeah. I thought you were talking about specifically the object, not the whole thing. Yes, when these come out front, I'll call it 2 ln of x minus 1/2 ln of 4x plus 1. And you can write that as 2 ln of x minus ln of 4x plus 1 over 2, like that. Yeah, you can write it both ways. I would actually prefer the one in the middle, because then 1/2 is still a coefficient, and coefficients still go up to exponent land. I can interchange those two a little easier if it's written as a coefficient instead of a denominator. Okay? Something to be aware of. Let's say that was 3 root of 4x plus 1. I'll see kids do this because these two are smashed together and multiplied. They'll have ln of x, bring the 2 out front, minus ln of 3 plus ln of 4x plus 1, bring the 1/2 out front. Why is this wrong?
Oh, no.
These two may be multiplied, but aren't both of them on the denominator. If they're both on the denominator, you are dividing by both of them. Okay? So both of them will be negative. Another way to look at it is if I rewrote this as a singular product, that's the ln of x squared times 3 to the negative first times 4x plus 1 to the negative first. And then those negatives come out front as coefficients, and that's what subtracts them. Okay? So everything on the denominator is subtracted. Break them up. Let's see what you can do. Always start by, if there's coefficients in there, break them up by prime factors. Coefficients get broken up into prime factors. I honestly think the expanding is the toughest part of this, just because those prime factors might get you. This is wrong. What's wrong? Okay, you caught both of them. Need to break that 6 up into 2 times 3. But then, look at the original problem. It is log base 13. I can't just call it log because that's base 10. I need to have that little 13 on all these. Okay. Another error I'll see is someone will put a 4 in front of this one as well. They'll try to bring that 4 to both of those. Remember, if there's no parentheses, then it's only touching what it's touching. The 4 only applies to the C because that's the only thing it's touching. Once it has parentheses, okay, now everyone inside the parentheses gets that exponent. Okay. The next one. This is a sum. A sum cannot be broken up in terms of factors. So that's just the ln of 3y plus 2. I cannot break that up. Minus, turn 4 into 2 squared. Ln of 2 squared, 2 comes up front. Minus ln of y to the 1/3, bring the 1/3 out front. Okay. So I hope you're getting that idea that it's really better if you rewrite the problem almost as all of its prime factors and exponents instead of radicals. Do all that first, then break it up. Okay? Curious, because I usually see this as an issue. What if I backed up back here? No. Backed up half the class, right? What if that's 26? A to the third, B, C to the fourth. Exactly. So if that is log base 13 of 13 and log base 13 of 2, this becomes 1. So you don't leave it as log base 13 of 13. You would actually have just a plain 1 in front. Okay. I think it was Callie was asking that about if I had 1 over 2 squared for my ln. Yeah, you could have just 1. That is possible. Okay, what if I was doing this with a denominator? What if I had the ln of 1 over 3x to the 4th, y to the 5th?
1 minus ln 3.
But what's the ln of 1? Uh-huh. 5 ln of y. There we go. Since the ln of 1 is 0, I just wouldn't write that part. Okay? So you got to remember all those properties when you're expanding these. What's something ugly? Yeah, we're doing 8. Get him! That is an 8.
It just means that the one.
I think I can bring that 3 over. Maybe.
First to get it completely correct. Free Donut Friday. Completely correct.
I've already mastered the word triangle and it won't be hard. Keep going. Seems like it'll be a sequence.
No. I just gonna
Well, that's right. I remember this problem. Sneaky, sneaky. Can you break this up as absolutely broken up as possible? And then expand it. Nope. You still got more work to do there, Haas. Hmm. Close. Sports Center or Photo Math?
Sports Center.
Oh. Hmm. Nope.
No.
Swing and a miss.
You would see a bunch of stuff and be like, that is not you. I've seen your homework. That is not you.
Okay, there it is. Man, everyone else is just warming up to go up to bat. Jaden's over here like, yep, home run, I'm done. Yep. Well, okay, it was kind of like it was kind of like it bounced off the outfield and then into the stands, but yes. What can you factor out of this? But be careful. That whole thing is cubed. You didn't take out a 2. You took out 3 2s. Cubed. Okay. So say I go log base 8 of 4x plus 2 cubed plus log base 8 of x minus 4. And most of us are like, all right, fine. Like, I got that. 3 comes down here. Cool. But in here, that's 3 log base 8 of 2 times 2x plus 1. So when you break this up, you have to understand that the 3 is going with it. They are both being tripled because they would both have that exponent. Because I ain't taking out just 2, I'm taking out 3 2s, which means 3 log base 8 of 2 plus 3 log base 8 of 2x plus 1 . Okay, so that was the crack. They jump, they're gonna catch it, it bounces off their glove and into the stands, because if I bring that back up here, what is 2 to the third? 8. Log base 8 of 8 is 1. Okay, so that one's extra tricky, because not only am I able to factor something out, but I have to factor out understanding that because it was cubed, I factored 3 of those 2's out. Okay, extra tricky. Did that too fast. Almost want to renege on my donut offer. I won't, but. Okay, y'all cool with the radicals? Just make sure that they're rational exponents. Okay. Condensing, I honestly believe, is easier because I don't have to look out for those what else could I break up. Instead, you're just trying to smash it all together. It is easier to just throw everything in a pile and mix it up and call it casserole than it is to make a whole bunch of different dishes. Okay? I see a 4 that can come up. I see a -1/3 that can come up. So I've got log base 3 of x to the 4th upstairs. And if I have something to the -1/3, or minus that thing to the 1/3, tells me it's headed downstairs. So I'm going to have a 3rd root of x plus 6. Now there are debates as to whether this is actually simplified. This is how some of the previous problems looked. But is it a simplified expression? No radicals downstairs. So I am okay most of the time with you leaving it like this, but you need to be aware that you might have to multiply by another what? Not just x plus 6. Squared, because I need 2 of them. This is 3rd root. I need 3 of them to get out of radical jail. So I need to multiply by x plus 6 squared cube root. Now I've got 3 of them to get out of radical jail. In fact, I might just require this so that we get the practice with it. Okay, so the actual answer is log base 3 of x to the 4th times 3rd root of x plus 6, the quantity squared, all over x plus 6. Because I need to rationalize my denominator. Ew. Okay. I mean, it's not bad. You just have to remember how radicals work. It's a cube root, so I need 2 of them to get out of radical jail. The other one's a little easier. I'm bringing 6 up top. I'm being 3 up top. It is a sum of logs, so I just multiply them. It's going to be the ln of x minus 4 to the 6 times x to the 3rd. I can just leave it like that. I suppose if I wanted to be a little more prim and proper about it, I should just have x to the 3rd as a coefficient. Something to note is that the book does not put these parentheses here. I don't particularly like that because, for example, right here, if I wrote that as the ln of x to the 3rd, x minus 4 to the 6th, if they don't use parentheses, is that entire thing the object of the log? Or is that the ln of x cubed times x minus 4 to the 6th? Right? Is it grouped together like this? Or is the object of the log only x cubed? So the book will not use parentheses on almost all of their problems. I dislike that. I'm going to tell you just, if this entire thing is the object of the log, put the entire thing in parentheses. It's just safer. Just like having the I in front of the radical was safer than having it at the end, even though that's proper. Just for all of you grumbling about that 29 out of 30, 28 out of 30, 27 out of 30, and it's all these itty bitty little things, that's one of those little things that you can be careful with. Okay? Change of base formula. A couple of you, I heard you complaining as we were doing this yesterday with your calculators, because some of you are rolling old TI-83s. You say, how am I going to put log base 4 of x into my calculator? Well, if you're on an older calculator, you can't. We add ancient magic, the change of base formula. Change of base formula says as long as I'm using a common base between the two, if I had something like log base 4 of 3, I could call that log of 3 over log of 4. Because now both of these are common logs. They both share a base. If I said, what is log base 13 of x, and I had no way to plug that in my calculator, I would write that as log of x over log of 13. That's my change of base formula. And the way it works, when you see it happen, you're like, oh, I suppose. But not many people would think of doing it this way. If I have log base b of x, what's anything divided by itself? 1. What's anything times 1? Itself. So I can multiply this by big nasty over big nasty, and it's still the same thing. Just gave it a little bit of makeover. Well, what they do is say, I'm going to choose some other base. Multiply this by log base a of b. Whatever my base is here, I'm going to pick something. And you're like, well, what does that do for me? This is now a coefficient of that. What can I do with coefficients of logarithms? They can be coefficients or they can be exponents. This whole honkin' thing can now become an exponent. You're like, why would I do that? That's disgusting. Because this part now cancels. And I just bring that x down. And it turns into that. Okay? So that's why it works. The practice of it is really easy. I'm just going to grab buttons on my calculator. If I don't have a log base button on my calculator, I'm just going to use log of 5 over log of 3 to get my decimal approximation. This is how we did it back in the day when we just had the lame little like business math calculator, barely had square root on it. Like, that's how we did this. Okay. Now that works for any base. Double check it. What if I use base E on both of them? They should come out the same. And I really want to point that out to you because our book is fond of using ln in their solutions. They would much rather use ln than common log when they write out the solutions for these. So you need to be aware of that. Here, same thing. ln of 6 over the ln of 1/2. And I'd go get my decimal approximation. ln log. If you want to be really facetious about it, what if I used log base 3 of 5, log base 3 of 3? Well, now it's over 1 and it's the same thing. But I could still type that in my calculator, couldn't I? I could do log base pi of 5, log base pi of 3, and it will still work. Okay? And if I can use any base I want, well, that's going to help me when sometimes they share a base. Then I won't need a calculator at all. I'll be able to just write it out in the same base. So I don't see a need to monkey button push all of them. How about you just do 5a and see if it comes out decent? You know what? Do it with common log and natural log. Make sure that it's correct. Okay, so if you're ever rocking a scientific calculator, if you're on an older 83 Ti and you don't have that log base button, well, you just use the change of base formula. If I wanted to graph this in an old TI-83s, the emulator on your laptop, in Y1, I would say log 33 divided by log 15, like that. That's how you graph those in old graphing calculators. Use the change of base formula, okay? Just to make sure we're all getting a boot the same thing. What do you think? Log of 4212 over log of 78. ln of that over ln of that. What is it?
1.916.
Yay or nay? Okay. All right. The word problems for these. Blah, blah, blah. Jam it in your calculator. That's it. Okay. Something, something, music I don't understand. Sense. Do you actually use sense in music? Where's my band and choir geeks? Do you actually use musical sense? Is a unit of relative pitch. 1 octave is 1200 cents. This sounds like the old, my car gets 38 rods to the hogshead kind of units of measurement. But, blah, 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 beginning with A, ending with B, find the difference in pitch. Could you just jam these two numbers in there and dump it in your calculator? Okay, cool. So then your notes for the word problems of this entire section are use your calculator. That's it. Just dump it in your calculator. Could you, at some point along the way, simplify the expressions? Yeah. Am I still going to have to use my calculator? Yeah. So why not just type it in the first place? Okay. And that's that, right? Yeah, that's it. Okay. Donezo.